This will be for the Khan Academy exercise, limits at infinity of quotients. All right, so I may add to these notes as we go along. Okay, but for starters, you want to look at the variable with the greatest exponent in both the numerator and denominator. Okay, you can ignore the other terms. Okay, so right here we have the limit as x approaches infinity of this right here. We can see the greatest exponent is 3, so we're going to ignore the negative 5x. On the denominator, again, the greatest exponent is 3. We can ignore these terms. And why is that? Because if x is going to infinity, these terms right here are going to control where the graph goes. Okay, because if you plug infinity in place of x, the greater exponent is going to increase or decrease much faster than the other terms. All right. So basically, you can ignore the terms with the lower exponents and just look at the greatest exponents. So if you have the limit as x approaches infinity, all right, and we have 3x to the third over x to the third. Well, what happens here? Well, the x to the third divided by x to the third just cancels or drops out. Okay, and basically the limit is just approaching 3. So it's that simple, okay? Especially when the exponents match, you just look at the coefficients here. The coefficient here is 1. It would just be 3 divided by 1. Answer C. All right, so once again, we have the limit as x approaches infinity. In the numerator, greatest exponent is 3, so we keep that. Denominator, greatest exponent is x squared. We ignore the 20x. Okay, so basically we have the limit as x approaches infinity of 4x to the third over x squared. Okay, and if you divide x to the third divided by x squared, that's just x, and we still have the 4. Okay, now x is headed to infinity. So if you just had 4x and this was going to infinity, the whole thing, 4x, heads to infinity. Okay, so basically the answer here is just infinity. Once you take positive infinity and plug it into the 4x, the whole thing just heads to infinity. Okay, if you kept plugging in larger and larger numbers for x, the 4x would also approach infinity. So that's it. And this makes sense. If you took infinity and you plugged in infinity numbers, positive infinity in place of x, the numerator would increase much faster than the denominator because the numerator is x to the third and this is x squared. If the numerator gets bigger much faster than the denominator, it's going to go toward infinity. So that's basically it. And when the limit goes toward infinity, we say it's unbounded. So that's answer D. Okay, these are just regular finite numbers, but if it goes to infinity, it's unbounded. All right, once again, x approaches infinity, and we want to work with this function here. So, as always, only look at the greatest exponent in the numerator and denominator. Ignore the lesser ones. Okay, so we're looking for the limit as x approaches infinity. And we have x squared over x to the fourth. All right, and that is just going to be 1 over x squared. Right, x squared divided by x to the fourth. If you just subtract 4 minus 2, it's x squared. Okay, if x approaches infinity and x is in the denominator, that means you are going to get 1 And if x is going to infinity, you're going to get a really large number in the denominator. Okay, the numerator stays as 1, the denominator gets bigger and bigger. If it's 1 over a really large number and this number keeps getting larger and larger, that just means it approaches 0. Okay, and again, this makes sense. If you're plugging infinity in place of x, x to the fourth is going to increase much faster than x squared. That means the denominator is going to get larger much faster than the numerator. So if you have a small number over an ever increasing larger number, that whole thing is approaching 0. Okay, it's going to be a fraction that gets smaller and smaller and head towards 0. All right, so these are pretty easy. All right, only look at the greatest exponents. All right, if you have negative 4x to the third over 2x to the third, that's just going to be negative 4 over 2, which is just negative 2. Simple. All right, so to sum it up, if the limit goes to infinity, either positive or negative, it's considered unbounded. All right, so the three scenarios: as x approaches infinity, if the degree of the numerator is greater than the degree of the denominator, the limit approaches infinity. That means it's unbounded. If the degree of the denominator is greater than the degree of the numerator, the limit approaches 0. If the degrees are equal, the limit approaches the quotient of the coefficients. Okay, it's going to be the numerator divided by the denominator. You look at the coefficients if the degrees are equal.